look at our problem here. So we've got, this is a common problem in calculus. We want to get the volume of a solid generated by revolving a certain region, okay, with these boundaries. Okay, so let's look at an illustration. Good to draw these things. Helps you think a little bit, gives you some intuition. Okay, so here's our shaded area, and it's going to rotate around the line x equals 2. All right, so there it is rotating, and as it rotates, it's basically carving out this three-dimensional shape. Okay, there's the function. It's in terms of x, which might look unusual. It's actually helpful in this case. So we're going to use the disk method, and here's a disk. It's a sample. All right. Now, of course, the disks that we're going to use in integration are going to be much skinnier than this one. Okay, but this is just to get an idea. So this is the width of the disk. Okay, and then we're going to need the radius of the disk, which is half of length, right? And so let's look at the volume of this particular disk. Okay, so it's just going to be pi r squared times the width, dy. So here's the radius. Okay, the radius is 2 minus the value of the curve, okay, in terms of y. Okay, so it's 2 minus whatever this value is. This is the x value. All right, so we'll square that. And then we're going to look at the volume of it. Okay, that's before, sorry, simplified it before we square it. Okay, now we square it. Right, and we have an expression for each one of these disks, which is pi r squared dy. Okay, and integration takes each one of these disks and sums them up to get the total. So let's look at the final calculation. So our volume is the integral in terms of y from 0 to 1 pi r squared dy. And all we need to do now is use the power rule to integrate this. Pretty easy stuff, no big deal. The key there is to get r squared, I think that's the key. All right, that's the final answer. Hope that was useful.